Hello dear friends, welcome back to my YouTube channel Maths by AMS. In my last video we discussed 1 mark and MCQ questions from the SSLC model paper 1. In this video let us discuss 2 mark questions from the same model paper. The first question in 2 mark section is from the chapter Arithmetic Progression. So let us see what are an internal choice is given for the first question itself. We'll try to solve both the question. So first one, in an arithmetic progression, S20, they given S20 is equal to 820 and A20 is equal to 79. Here you can observe we need to find out sum of the 20th term and 20th term is given. So that means we can use the second relation, that is A plus An formula here, as we know the nth term. So we all know Sn is equal to n divided by 2 into A plus An. So if n is equal to 20, if I put, I will get S20 is equal to 20 by 2 into A plus A20. By substituting the value of S20 as A20, this is equal to 10 into A plus A20 is 79. I can cancel 10 ones and 1 0 will get cancelled here. So I'm going to get 82 is equal to A plus 79. If I shift that 79 to left side, I'm going to get 82 minus 79 is equal to A. Therefore, the value of A is equal to 3. So this is the value of first term, that is A is equal to 3. Now in the same question we have another question, that is how many numbers between 201 and 401. We need to find out between 201 and 401 multiples of 6. 1 minute. Multiples of 401 multiples of 6. As we all know, 201 is not divisible by 6. So it goes 6 3s are 18, left with 2, 21. 6 3s are again 18, left with 3. Remainder we are getting 3, so it is not 0. Therefore 201 is not exactly divisible by 18. So that means as we have 3 here, to get 6 I need to add 3 more. That means you add 3 to this one. So if I add 3 to 201, the remainder will become 6. So that means again it is further divisible. So I can say 204 is divisible, 210 is divisible. Similarly you can check with the 401. So this 6 are 36, 4 left, 41. Again 6 6 are 36, I left with 5. So as we are getting 5 as a remainder, it is also not divisible by 6. I can make 401 by adding and also by subtracting something. I can make that number divisible by 6. But if I add the number to this 401, it will give a number which is more than 401. So in the second case I can't add here, so I need to subtract. What I have to subtract? I have to subtract 5 here. ಈ 5 401 ಇಂದ subtract ಮಾಡಬೇಕು. ಎಷ್ಟಾಗುತ್ತಾಗ? So it becomes 396. So these are the numbers starting from 201 and last number is 396. Here A is 204, D is 6, An is equal to 396. So I need to find out how many. N I have to find out. For this, let us use An formula. An is equal to A plus n minus 1 into D. An is 396. A is 204. N value I need to find out. D is 6. 396 minus 204 is equal to n minus 1 into 6. 6 minus 4 is 2. 9, 1 divided by 6 is equal to n minus 1. 6 3 is 18, 6 2 is 12. So this is what the answer. Now after this implies what is the value of n? 32 plus 1, that gives 33. So you have to conclude your answer with statement there are 33 multiples of 6 between 201 to 401. Now I'm moving on to the second question. I need to solve this question or this pair of linear equation by any suitable method. I'm going to use elimination method here. So just by adding plus y minus y get cancelled, we are going to get 5x is equal to 15. X is equal to 15 by 5. So we will get x is equal to 3. Now if we put x is equal to 3, we are going to get 2x plus y is equal to 8. 2 into 3 plus y is equal to 8. Y is equal to 8 minus 6. Y is equal to 2 is the required answer. So therefore solution x comma y will be 3 comma 2. This is what the required answer for the question number 18. Now we'll move on to the third question. Find the discriminant of the quadratic equation. I need to find out discriminant of a quadratic equation. So quadratic equation is given, that is 2x square plus 3x minus 7 equal to 0. A is equal to 2, B is equal to 3, C is equal to 7. The discriminant of a quadratic equation is given by b square minus 4ac. That is 3 square minus 4 into 2 into minus 7. So d is equal to 9 plus 4 to the 8, 8 7 is a 56. Right? So d is equal to 56 plus 9 is equal to 65, which is greater than 0. Therefore, what we have to do, we have to even tell the nature of roots, as the discriminant is positive here. Roots of the given quadratic equation are real and distinct. So this is what the first question from the question number 19. So again internal choice is given for this. 2x plus 3 into x is equal to x square plus 1. So here if you multiply 2x into x, 2x square. I need to write it in standard form. 3x is equal to x square plus 1. And simplifying, I will get 2x square plus 3x minus x square minus 1 equal to 0. 2x square minus x square is x square plus 3x minus 1 equal to 0 is the required quadratic equation. This is what my required answer. Now we'll move on to the question number 20. Prove that root 5 is an irrational number. Question is from the chapter real numbers. Very first chapter. I proved the same question many times. You can refer my previous videos to get the solution for this question. We are going to use contradiction method to prove this. Contradiction method to prove this. You can check the solution in my previous videos. So I'm going for question number 21. Find the coordinates of the point which divides the line segment joining the point 1, 6 and 4, 3 in the ratio 1 is to 2 internally. That means there is a line segment joining 1, 6 and 4, 3. So therefore it becomes x1, y1, it becomes x2, y2, this becomes m1 and this becomes m2. What is the formula to find out x? m1 x2 plus m2 x1 divided by m1 plus m2, and substituting we'll get 1 into 4, 2 into 1 divided by 1 plus 2, that is 6 by 3. The x coordinate is 2. Similarly, use the section formula to find out y coordinate. m1 y2 plus m2 y1 divided by m1 plus m2. So this gives 1 into y2 is 3 plus 2 into 6 divided by 1 plus 2, that is 3 plus 12 divided by 3, 15 by 3, that is equal to 5. The required coordinates of the point, coordinates of point of division, is x coordinate is 2, y coordinate is 5. This is what the required answer for this question. Now I am going to take the next question. Question from the chapter trigonometry. I need to define tan p and also cot r. Whenever I consider the acute angle p, this will become opposite and this will become adjacent, and this is what hypotenuse. Now if I want to find out tan p here, the definition is opposite divided by adjacent. Therefore tan p is equal to opposite side is 5, adjacent side is 12. The same question now, if I interchange r as the acute angle, then this will become opposite side and this will become adjacent side. In this case, cot r is equal to adjacent by opposite, that is also equal to 5 by 12. Now I have to find out this. So these are the thing they ask. We have to just find out tan p and cot r for the given triangle. Now I'm moving on to the question number 23. In the given figure, CP and CQ are the tangents to the circle with center O. ARB is another tangent at R, so that the perimeter of a triangle CAB is twice the length of CP. So before going to take this problem, you can see from A, a pair of tangent is drawn here. Similarly, from B, a pair of tangent is drawn. So in the solution part, I can write from figure AR is equal to AP. Let us call it as X. Idunu X anukothini, idunu X anukothini. Similarly, BQ is equal to BR. So let us call it as Y. All these two statements from theorem 2. So idunu enu anukona Y, Y. Now I have to find out perimeter of triangle ABC. Perimeter of triangle ABC is equal to AC plus AB plus BC. I can write AB, I wrote twice. AC, AB can be written as, by seeing the figure, can I split AB as AR plus RB? So now I'm going to get AC plus, what is AR is equal to, that is also equal to AP. What is RB is equal to, that is also equal to QB, so plus BC. By grouping these two and these two, AC plus AP will be equal to CP and QB plus BC is equal to QC. Again from theorem 2, we all know length of QC and length of BC are equal. Therefore QC plus L I can write CP. Therefore that is equal to how much? 2 times the CP. This is what the answer for question number 23. Quite tricky. You have to practice more time to get clarity in this particular problem. Now I'm moving on to the question number 24, last question in this section. So the thing is, from the chapter real numbers, the product of HCF and LCM. HCF and LCM is given, that is 216. If one number is A is 42, then find the other. B I have to calculate. We all know HCF into LCM is equal to 42A into B. So therefore 2016 is equal to 42 into B. Therefore B is equal to 2016 divided by 42. 221 is 208, 2 1 is 0. This is not, sorry, this is not possible. 1008 is 3 7 is 3 3 is 1 carry, 3 3 is 1 carry 18, 3 6 7 1 is 7 4 is 28, 5 carry 7 8 is. So another number is 48. Now after this, finding another number, also find the HCF of these two number. I need to find out HCF of these two number, that is what, 42 and 48. Just you find out the prime factorization and find out the HCF of these two. You can see I wrote the prime factorization here. So the common factors are 2 and 4. So it's 3. Therefore, the answer is 2 into 3, that is equal to 6 is the required HCF. Thank you. We'll meet in the next video with the solution for 3 mark question. Thank you.